Hello everyone. Welcome to the NASA Earthdata webinar, Beginner's Tour, NASA EOSDIS Data Discovery and Access. This is your host, Geraldine Tuart, representative from the EOSDIS User Support and Communications team. I will be your host for today because our usual host, Jennifer Brennan, is today's speaker. While everyone is logging in, we have two polls at the bottom of the page we'd like you to answer. It's 2 p.m. Eastern Daylight Savings Time, so why don't we get started? Let's begin by going over a few housekeeping items related to this webinar. Due to the large number of participants and to ensure best audio experience, the conference has been placed in silent mode. However, if you have any issues or questions, please enter them into the Q&A pod located on the lower right-hand side of your screen. This works like a chat. This webinar will be recorded and posted to our Earthdata Adobe Connect catalog. The URL will be provided on the contact slide at the end. All presentation files will be available for download at the end of the webinar. The webinar is 1 hour long. 45 minutes are allocated to the presentation and live demonstration, and then 15 minutes for the question and answer period. After the speaker has finished her presentation, we will then move to the final set of polling questions. The question and answer period will follow after the final polling questions. As mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar except during the live demo by using the Q&A pod. Due to the large number of participants, questions will not be answered using the raising hand function. It has been disabled. We will take all questions verbally at the end. There's one final note. Depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 for those who wish to stay on the line. Let's move now to the agenda. The first 15 minutes or so, we will provide you with an introduction to NASA EOSDIS data centers and their data holdings. During the next 20 minutes, we will introduce two of the key data discovery and data access tools to get you started. We will wrap up with the tips on where to go to find help. It is my pleasure to introduce our speaker today, Jennifer Brennan, who is the NASA EOSDIS User Support and Communications Lead for the EOSDIS project. Jennifer?
Before we do that, can we do a quick audio test by way of those of you listening in by computer? Are you able to hear us? Please type into the Q&A pod here. Yes? Okay, believe it or not, I'm usually the host, and for the first time ever, my computer actually got disconnected out of the 15 webinars we've given. So that's probably what accounts for the lag that you had for a second there. So let's go ahead and get started. Thank you, Geraldine. I'm the User Support and Communications Lead for the EOSDIS project. Over the past 13 years, I've been working with end users, a lot of times at science conferences, by providing information about how to find, access, and use NASA's EOSDIS data sets, data tools, and services. During today's webinar, I hope to provide you with knowledge and information that enables you to begin searching for and ordering NASA Earth Science data for your research or other requirements. It is my intent that by the end of today's webinar, you have an idea as to what to do to get started and where to start looking for the data that you need. With that, let's get started with the presentation. I will start off by providing an introduction to NASA EOSDIS and its data holdings. So who are we and what do we do? NASA's Earth Observing System Data and Information System, or EOSDIS, is a key core capability within NASA's Earth Observing System program. We provide end-to-end capabilities for managing NASA's Earth science data that comes from a variety of sources, including satellites, aircraft, field measurements, and various other programs. We also provide land validation data sets. There are 12 discipline-specific distributed active archive centers that process, manage, archive, and distribute a variety of Earth system science data. Additionally, for the EOS missions, a sister project to EOSDIS here at Goddard, called the Earth Science Missions Operations Project, or ESMO, is responsible for providing the command and control, scheduling, data capture, and initial processing capabilities. So the next slide here provides you with a visual as to where all of our 12 DAACs are located. We actually have 4 of them here at Goddard. We have the Crustal Dynamics Data and Information Systems. We have the MODIS Level 1 Land and Atmosphere Archive. We have the Ocean Biology Processing Group. And we also have the Goddard Earth Science Data and Information Services Center. In fact, we have more Earth scientists concentrated here in Greenbelt, Maryland than any place in the world. So let's talk a little bit about the data. What does a beginner need to know about our data? Well, to start with, our Earth science data range from near real-time data sets to airborne data to remotely sensed data and validation data products, field campaign data, and human dimensions data products. The majority of our data is publicly available and accessible online. The temporal and the spatial coverage will and does vary depending upon the platform, the sensor, the campaign, and the data product. That being said, we do have historical satellite data beginning from the mid-1970s through the present. Okay, a little bit about the EOS data format. So most of NASA's EOS satellite data is in either an HDF or an HDF EOS format. Okay, and what that means basically, without looking up what the definition for the format, what you really need to know is that today's GIS packages can easily read and visualize this data format. There are also a variety of other data outputs that are available when you order, including KML, GeoTIFF, NetCDF, and binary or ASCII formats, but this will depend upon the data product. There are also a number of tools that allow you to process and convert your data into GIS formats. So the next slide features a short animation here. I thought it would be neat for you to see as to where these data products are coming from. Is anybody seeing the animation? Hold on a moment. Stay tuned. Mine is actually not advancing here. Interesting. Okay. Hopefully this goes off without a hitch. Okay, so this gives you an idea of the orbit and the coverage for our satellites that are currently representative of our satellite fleet. Our newest satellite, GPM, or the Global Precipitation Mission, a partnership between NASA and the Japanese Space Agency, launched on February 27th, 2014. And you'll see that it's identified by the red, okay? And that's the follow-on mission to TRMM, or a Tropical Rainfall Measurement Mission. The GPM data will feature increased resolution and coverage over TRMM, so that's pretty exciting. Since I will mention several of our key Earth-observing satellites later, note the Terra platform, which is the flagship satellite for NASA's EOS program. Okay, and that was launched in 1999. Terra is the first EOS, or Earth Observing System platform, and provides global data on the state of the atmosphere, land, and oceans, as well as their interactions. I see that it's freezing up a little bit here, with solar radiation and with one another. Sorry about this. Looks like it's reloading. Crosses the equator at the same time daily at 10:30 a.m. Okay, the next is Aqua, launched in 2002, crossing the equator at the same time daily at 1:30 p.m., with instruments on board that are taking measurements of Earth's water. The third in the fleet, which is Aura, launched in 2004 with instruments on board that measure atmospheric parameters. Aqua and Aura are also part of our A-Train, or afternoon constellation, that also includes two other satellites, Calypso and CloudSat. So the four in the A-Train constellation are Aqua, Aura, Calypso, and CloudSat. And finally, I'd like to draw your, I don't know if it's freezing up for everybody else. The raising hand function here, we won't answer questions during the webinar. Okay, we've got pretty full house here. The final satellite I wanted to draw your attention to was the Aquarius satellite measuring sea surface salinity. Sorry for the glitches here. Okay, let's move on to our next piece of the presentation. So what else? We've got a lot of data, and to put this into context, I've prepared this slide for you here. We hold a very diverse range and broad range of data products. And so here you can see, I wanted to point your attention to the number of unique data products, as well as the distinct users of the data products, along with, the total archive volume. I think that really speaks for the breadth and the depth of our data products. Okay, and the next slide. The question is, and probably a question for those of you who've not used our data products before, you may be wondering, well, what types of data do we have for your research and or applications needs? The next slides will highlight for you. We'll start off with the near real-time data. All right, so the land atmosphere near real-time capability for EOS, or LANCE, provides free access to Earth science data and imagery within 3 hours of observation. And you can see the list below here highlight the sensors and the specific data products that are available with their associated latencies. Again, there is a very broad range of data for a large number of parameters. In the next slide, we will highlight our atmospheric data. Here you have an idea as to the types of measurements that are being taken by the suite of platforms that you could see within the data animation. Okay, and moving to some representative data imagery. The image on the left, features the ozone monitoring instrument, or OMI, nitrogen dioxide, NO2, column amount values overlaid on a MODIS moderate resolution imaging spectral radiometer, or MODIS, true color image. The pink is indicating elevated NO2 from intense fire activity just east of the Yarnell Hill fire, which is indicated by the black triangle right in here. Okay? The image on the right shows heavy rainfall extending from Texas to the Great Lakes. In June of 2013, there was some extensive flooding from heavy rainfall that occurred in Missouri when a levee was breached. The Tropical Rainfall Measurement Mission near real-time multi-satellite precipitation analysis rainfall data are shown here for a 3-week time period from May 14th to June 4th, 2013. So some of you may recall in mid-January of this year, the snow and ice storm that hit the southeastern United States. This image on the left shows snow on the ground in parts of northern Georgia, northern South Carolina, eastern Tennessee, and western North Carolina as captured by the MODIS instrument on board Terra. And I should tell you that MODIS is an instrument on board both Terra and Aqua. It's taking snow and ice measurements, water measurements, land measurements, and atmospheric measurements. So it's a very dynamic and kind of you could almost call it a workhorse sensor across our platforms. Okay, the image on the right, I really wanted to give you an idea as to the different types of data when showing these data images. So you can see here that this is representative of one of our airborne campaigns called NASA Ice Bridge. This is an airborne campaign measuring and surveying Earth's polar regions. This photo here is from a P3 and is showing the mountains in Alaska's Brooks Range as seen during their Ice Bridge survey flight from Thule, Greenland to Fairbanks, Alaska. And this is a photo from just recently, within the last couple of weeks. Okay, the next slide shows two examples of our human dimensions data. These data are pretty different from nearly all of the other data products that we hold. And I should say that a lot of them are available in a ASCII or binary Excel format type of format, which differs greatly from using HDF or HDF EOS. Okay, the image on the left is a environmental performance index image, and it ranks countries on their environmental performance over the last decade, showing which countries are improving over time and which are declining. Red indicates strong decline, and Kelly green represents a strong improvement. So the image on the right is called our anthropogenic biomes data product and is illustrative of the human impact to Earth's biomes, which are defined by population density in this particular data set and vegetation cover. So the map, if you will, is providing a more contemporary view of the terrestrial biosphere in its human-altered form. Moving on to our land measurements, okay, just to give you an idea. The image on the left was acquired by the Advanced Spaceborne Thermal Emission Radiometer instrument on board the Terra satellite. Now this is actually an on-demand sensor and has a similar resolution to a 30-meter Landsat scene. We do have 15-meter data for this specific sensor. And here you can see, although it does cover a much smaller area than Landsat, it's only 60 kilometers by 60 kilometers, okay? This instrument was tasked to observe Alabama on May 4th, 2011, revealing the tornado track, which is shown in light blue, passing through Tuscaloosa at the lower left and extending to the upper right. On the right-hand side, you've got two things going on here. There's actually two separate data products. So the first one would be our MODIS visible radiance data product. And with that, you can see our MODIS, these red pixels here, our MODIS thermal anomaly data. And essentially, that particular data product is a near real-time data product, and it can pick up fire activity, the sensor, based upon heat intensity. So it represents activity within a 1 kilometer to 1 kilometer area, okay? Not necessarily the extent to which something is burned, because it could be a very small, very hot fire. So this is the California Rim Fire on August 22nd, 2013. Ocean data. Now NASA actually has two different discipline ocean programs. The first one being our physical oceanography the two are the physical oceanography program and the ocean biology or ocean color program. Okay, so the two images on the left here, you can see data imagery from our ocean color program. The warm heart of the Gulf Stream is readily apparent on the left-hand side, and this is actually a MODIS sea surface temperature image. So as the current is flowing toward the northeast, it begins to meander and to pinch off the eddies that transport warm water northward and cold water southward. The warm water creates a higher biomass region to the north of the current, and you can see that it's pretty evident when you look at the right-hand side image, which again is a MODIS data product, but it is a chlorophyll concentration product. These images were acquired from MODIS onboard Aqua on April 18th, 2005. And again, the difference between those two, I don't know if you noticed this in the beginning, but they're taking measurements, Terra and Aqua are taking measurements in the morning and in the afternoon. So that's the difference between the two. If I say MODIS on board, Aqua or on Terra. So that's the difference between the two. All right. The image on the right is the latest image from the Ocean Surface Topography Mission, or JASON-2 satellite. JASON-2 is actually a follow-on providing an uninterrupted time series for sea surface height that originated with our Topex Poseidon platform. Jason uses radar altimetry to collect sea surface height data. So these images here, or I should say this image here, shows you sea surface height anomaly with the seasonal cycles removed. So the effects of summer, fall, winter, and spring have been removed. And I should also note that each image is a 10-day average of the data centered around the date that's indicated. So in this case, March 7th, 2014. So you might be wondering, there's so many different NASA sites out there and NASA data access tools out there. Where should I start? Okay, and it turns out we do have one centralized place for you to look for information, data, services, and tools, and that is through our NASA Earthdata website. So this website is designed to help facilitate an end user's discovery of the data information, the services, and the tools. And why don't we come along on a brief tour here? I've got some screenshots actually. So that's what how we'll address the, instead of doing a live demo. There are a few key features of the website that I'd like to quickly highlight for you on the following slide. So if you see here on the left-hand side, you can see that you'd be able to access the data discovery and access tool that I'll talk about just in a few minutes, Reverb, right, the first one, and then our data discovery tool is the second tool. So you can access both of those tools that we'll cover today from the home page. The search and order tools portion of this website actually has a listing from one of our publications that outlines the various tools organized by the feature or functionality of the tool itself. So your subsetting, your visualization tools. If you look at search and order tools, you will find not only a listing of some data center specific search and order, but also the other tools organized by feature and functionality. Okay, and moving on to the next. I also want to draw attention to the user resources portion of the website. You can find this from the main menu bar off the home page. It's called User Resources. This site is in the process of being revamped, but in the meantime, this is a good place to look for our communications products. And I'll show you, zoom into some of our key products in just a moment. Some of our tutorials and examples, although the most comprehensive view for our webinars, which have included step-by-step tutorials, will be on a later slide, okay, and some helpful URLs as well. So this is what our user resources, first page looks at. Now zooming in to our outreach products, the Earth Science Data Resources booklet is probably the core publication for this task. And it provides information or an overview of all of the data centers, more information about data formats, data processing levels. It provides the temporal and spatial coverage and a really concise, short paragraph describing which data products are available. So pretty much it's an all-in-one kind of booklet to help you find additional information you may need. The second one in the list, although very hard to see the thumbnail here, are our discipline dataset reference sheets. And you can almost think of these more so as a suite of cheat sheets that are organized by disciplines. So we've got a land, atmosphere, ocean, cryosphere, human dimensions, and then also a solar irradiance and radiance sheet. And these are listing, they're organized by parameter or measurement, and there is the long name for the data product, so what it would be called on their website, along with a link, and then data center information. And they don't represent the entire holdings, but rather those data products that are used most frequently in measuring those parameters, those that are used most frequently in research, for example, most popular, that kind of thing. Okay? And then finally, the third area would be our Sensing Our Planet. Again, you can find this from the user resources portion of the website. Sensing Our Planet is actually a publication, also online in PDF format, that has a collection of stories that are co-written by the PIs or the scientists on these various Earth science projects. It's not written as a science journal article, but for someone who's a specialist in one field, these really are helpful in giving the reader an idea as to how these various data products, and you can see here the data types are listed, are used in an interdisciplinary way. I think what's great about each one of these issues is that they've incorporated, in most cases, more than one data product, so you can really see how these data are used together. So I think that that's a useful resource. All right, moving along. Okay, so where do I start? All right, so now we've talked about a little bit about the data, right? We've said a little bit about the data format. We've got a lot of data. Let's talk first about our data discovery tool, okay? This is called the Global Change Master Directory. The GCMD, that's the acronym, because you know we love acronyms at NASA. We love acronyms. Okay, so this is a metadata directory to earth science data, services, and climate diagnostics, and it allows users to discover and access a collection-level metadata of earth science resources, but it is not your search and order tool. Okay, so though you can search by controlled keywords, free text, map, and date, it gives you a lot of very good information when you're trying to figure out which data product you should use regarding your spatial and temporal coverage, a really nice synopsis. You would not be able to order directly from this place. So let's take a look at it. All right. The home page of the GCMD is organized into three sections, or three sort of primary ways, three categories, I should say. You've got your data sets, your services and tools, and your ancillary descriptions. Okay? There are many ways that a user can search this directory. They can search by science keywords, instruments, platforms, locations, providers, projects, map date, and free text. And a user could also search by portal, which we will do momentarily. I will first show you the key user interface for search options, and then we'll move to the portal. So if I were to click on down here, search by data sets, and go, what I would see is the following. On the left-hand side, you can see how you might further refine your data sets by science keywords, platforms, instruments, etc. Okay? In our case, I want only to look at the EOSDIS data holdings. So I've clicked on portals, and here you see the second one is the EOSDIS portals. Now there are portals created for discipline-specific data centers as well, right? But this is a good entry place for one to search all of the EOSDIS holdings. So now we've clicked on there. For the purpose of demonstration today, here's what the portal looks like, organized by discipline or by topic. Today we are going to select atmosphere. So we've selected atmosphere. Here's what it will look like next. All right. We will now select aerosols. The next page would look like this. We will now be selecting our aerosol optical depth or thickness. Moving on to what you would next find. Here, what I want to do, I want to see all of the titles for aerosol optical thickness. Again, this is pulling the entries for all data products related to aerosol optical thickness. Okay? I've clicked on that. And for the purpose of demonstration today, we will select the Modus Aqua, or the third entry, near real-time aerosol 5-kilometer level 2 swath. Okay? You select that, and this is what a record or a return, here's what you'll find. Okay, you see you've got information, the summary for, or your diff for the data product itself. In this case, and this is the case, by the way, for all of the EOSDIS data holdings, you will have a link off the GCMD site to order the data. In this particular case, this is something that's held by our Modus Level 1 Atmospheres Archive. And so this link would take you directly there. You've got your spatial and your temporal coordinates. Moving down into the record a bit further, you have your data resolution, your user constraints, your keywords, information about the data center itself, you see down here, as well as your personnel, the technical point of contact. And something that I think is really useful is when they are listing publications or references. So you've got a couple of citations for each of these. You can really kind of read about how this data product has been used and cited in science journals. So I think there's some real value to that for somebody who is new. All right, so moving on. Now we've just talked about data discovery. Okay, so great. Now I've found some data sets, and I would like to get started searching for and ordering these data. So one of the primary search and order tools, I should say, that cuts across all 12 of the data centers is called Reverb. Reverb is the web front end to NASA's ECHO Earth Science Metadata Catalog that provides access to more than 3,000 Earth science data collections with over 120 million data granules or data sets contained within those collections. And what it will do is it will allow users to find data using very simple search parameters with keywords, or you can get very, very specific, including your spatial and temporal constraints, as well as searching by specific data attributes such as platform, instrument, or processing level. And what I will now do is walk you through, fingers crossed, a search, discovery, and ordering demonstration using Reverb. So with that, we will switch over to the live demonstration. And please stay tuned for a moment here. Okay. Uh-oh. Okay, I'm hoping, can everybody see this? I'm going to take you off mute for just a second and someone answer me if you can see this.
The conference is now in talk mode.
Everybody see my screen? Feel free to answer.
Yes.
Yes. Fantastic.
The conference is now in silent mode.
All right. So when you first visit Reverb, you will notice that there are 3 initial steps involved in discovering your catalog holdings. Okay, step 1 is going to be your select search criteria. Step 2, select your data sets. And step 3, discover your granules. So for this tutorial, we will be demonstrating a search for rainfall data from the Aqua satellite over the eastern region of the United States during April of 2011. Note that this search will involve a keyword, platform, spatial and temporal constraints to pinpoint exactly the data we're looking for. So once we find data matching these constraints, what I'll do is I'll go through the process of viewing the granules over this time period, as well as the direct download or ordering of these data using Reverb's download and ordering capabilities. So let's get started by selecting our spatial constraints. And I should point out to you that Reverb allows the user to select your constraints by using either a bounding box, a point, a polygon, 2D coordinates, or a place name. For this search, we're going to use a bounding box. Okay, and then I'm going to, as you can see, you can adjust this if need be. Okay, well, for the purpose of demonstration, this should be fine. All right. As you can see, and maybe you didn't notice this, but we started off with 3,331 data sets. It begins its search immediately, and what you see here is that we've narrowed it down already just by adding a geographic constraint to 1,936 data products right here. Okay. We can now further refine our search by selecting Aqua from the Platforms and Instruments menu over here to the left. So this will pull up the platforms and instruments. Now Aqua is the platform, Aqua is the satellite. So we will select Aqua when this loads up here. And let's scroll down. All right. Excuse me. As you can see, if you click on the eye, wasn't my intent to demonstrate that, but it's valuable information. You have more information about the instrument or the platform. And the same is true for all of those with the information icon. Okay, we'll click that off. This has now further drastically reduced our data sets to 256. Okay? So now what we will do is we will continue to narrow our focus by adding our temporal constraints. So for this particular demo, we will choose the start date of April 1st, 2011, and our end date of April 30th, 2011. Again, reducing it down to 193. Okay. Now, in our case, each time I've done this demo, it's been different. So what I want to do here is I am interested in the AMSR-E swath range data. Okay, so I will select that. I will check the box next to the AMSR-E. And you see that this has now populated my Discover Granules portion of the search. And what we want to do now, once we've selected this collection, we can look for specific granules if we know the granule ID. In our case, we're not doing that. But we can look at all the granules in the collection that fall within our search constraints by clicking the Search for Granules button, which is what we'll do next. This will call up a list, and just give it just a second, of all the granules that fall within our search constraints. Just take a second. Okay, so you see that 94 granules have right up here at the top, have shown up for our search. And what I want to point out to you next, we're going to actually take a look at our granules in just a moment to check coverage and best match for our initial constraints. But what I want to point out for you here is that there in the dataset bar, this is the dataset bar, there are 3 buttons. The first one will bring up data quality summaries, and the magnifying glass, and I will show you, will bring up more search options such as band availability, cloud cover, day and night flag, which is really a good thing. Depending on the data product, this would not apply to everything, but if you were looking for some Aster data, for example, if you remember the high resolution data product for the tornado, cloud cover would very well be something that maybe, you you only want cloud cover percentage within a certain range. So this is, your additional search options or refinement options here for the magnifying glass. And then the eye icon is going to be your, additional metadata information. Okay, so under the granules section, right, what we're going to do is we are going to, first I should probably go over this with you. There's an option to add all of your granules to the shopping cart right now if you wanted to, although we will not do that because I don't, that'll take a bit to have loading the 94 granules, but you could click on the all in the shopping cart right here and it would highlight all the granules and add them to your shopping cart. Okay, otherwise by clicking the shopping cart next to each individual granule, we'll add them in. But in our case, what I want to do is I want to take a look at the map view. I want to know where do each of these swaths intersect with our initial search. Okay, now if you scroll down, you see our search here, our geographic constraints, not exactly what I was going for, but that's still fine for demonstrating, what this tool is capable of. Okay, so here, in our case, what I want to do is I want to know what the first 4 granules look like on the map. Okay, and so you notice here there's an additional icon, right? This is going to allow us to view, and there's also browse imagery that's available. It's not available for all of the data products, but it certainly is available for a large number of the data products. So we're going to view the spatial extent for these 4 granules. Okay, and as you can see, just looking above, right, you can see where each of these swaths intersects with our initial search area. Okay, in my case, Today I am interested in the green, identified by the green, this granule here, and I am interested in the blue swath, and I want to add those to my cart by clicking on the shopping cart icon. All right. So we've moved those to our shopping cart. There are 3 ways to interact. Now we're going to click on the step 2, go to cart. So we'll view items in our cart. There are 3 ways to interact with the shopping cart. Let's wait just a moment while this pulls up. Just give it a minute here. Okay, you can order, download, or perform a service. Today we will not be performing a service, but I want to show you, you know, we will also not download the data. But what I do want to tell you is most of our data is not available any longer in, you know, in a media format, for example. So there are exceptions at our Oak Ridge DAAC data center. I think they still offer media for some of their field campaign work. What you're going to have is FTP push or pull for these data products. So why don't we go ahead and place an order. And I should tell you that I am signed in. A guest can browse, can search for, and look at you know, data within this particular interface without having to set up an account. However, when it's time for you to order your data, you do need to provide, you know, your contact information, and it's to your benefit to actually set up an account, because this way you've got the one account, and every time you order, you're not going to have to fill out your contact information, okay? So here are your options. You've got your FTP pull or push, as I was mentioning, and I want to just show you the media format. Well, in this case, let's see, check here for subsetting options. This may or may not apply to the data product you've selected, right? But in some cases, this is really important. Spatial subsetting or parameter subsetting, particularly for some of our Modis granules, which are huge. You may very well want to subset, or there are other data products that offer that as well. So I wanted to show you that. And what we will do is we are going to submit our order. Oops, you saw it all fields correctly. Okay, let me make sure I've got my, okay. And I want to, oh, so I've already, they already have my information. I don't know that this will ask for additional, but you would need to enter your, it's a small form that has you enter your name, your email address, your mailing address. And for setting up an account, there's more information as well. And I should tell you another advantage to setting up an account is that it saves your search parameters. So if you're working on some research and you want rainfall data, then maybe you want to look at some air surface temperature data or some you know, land surface data, you would have your geographic search, your initial search query would be saved, and you can still go back to that. So there's certainly an advantage to that. Once you submit an order, okay, what you will see, what you'll receive is an email indicating that they've received your order. Okay, in my case, I only want to receive notifications when the order reaches the final state. However, you could also ask to have email notifications at every stage of the processing for your order, and some people really might need that. But then you'll also receive instructions on how to download your data. Okay, so I'm going to close out of this and move on to the next portion. The presentation. Okay, so we've talked about how you can search across all of the disciplines. But there's also a way to search for discipline-specific tools, and I won't have time to go over all those today. If you're looking for discipline-specific tools, each data center offers discipline-specific tools to work with the data. And many of these tools have already been featured in our monthly NASA Earthdata webinars, with most of the demos providing step-by-step instructions. So I've included this URL for you here. Okay, this is our catalog, and all of the archived recordings are listed here. And you might need to know where to go to find help. There are many ways to find help, but there are two primary ways you really need to be aware of. The first being that each data center has a user services office that offers specific expertise and assistance to users in finding, accessing, and ordering data. So their services include, but are not limited to, expert assistance in identifying the appropriate data product and then going about obtaining those data. Access to data handling and visualization tools. There are RSS feeds. Many of them have social media accounts that you can link up to. Notification of data-related news. Some of them have, for example, data pools, which have, like a 2-year rolling archive of some of their most popular products. That's available to some of our data centers. Data subscriptions, and of course, technical support and referrals. So I've got a bit.ly link here for you that takes you to all 12 of the USDIS user support offices. The second primary way is to obtain help by way of the NASA Earthdata website. On the main page on the left-hand side, there's a blue feedback button or tab, and what you could either click that form and fill out, the questions that you have or the issues that you are experiencing, and someone from the Earthdata support team will filter that according to, the appropriate data center or the appropriate project. Or you could just email the support team directly at the support@earthdata.nasa.gov. And then finally, we want to hear from you. They're pretty new, but we have a Facebook account for which we will be posting regularly. It's just recently been approved. And here are our account addresses. And then I also have a Twitter feed. If you're interested, I see that some of you have actually subscribed to the mailing list listed last. If you're interested in receiving announcements for upcoming webinars, again, there's the bit.ly, and there's a short form you need to fill out to be on the NASA listserv for receiving these announcements. So what did we talk about today? What we talked about today is EOSDIS has a huge amount of global earth science data, information, services, and tools that are publicly available. We provide multiple ways to search for and find the data you need. So we discussed a key data discovery tool. That was the GCMD, and I should tell you there's a webinar for the Global Change Master Directory. There's also a link to a Reverb tutorial as well, although this is recorded and you can check back online. I'll provide those links to you. I'll probably upload those to the webinar, the Reverb tutorial. I don't think I included that in the useful resources, so I'll add that. And then we're here to help. So I talked a little bit about where you go to get help. User services support, NASA Earthdata support. Although I should underscore that there are a number of online resources, including tutorials, the webinars, data recipes, frequently asked questions at each of the individual data centers. And then again, finally, we would love to hear from you. Some of you I do hear from monthly when I host these webinars instead of being the speaker. So I'm so happy to see some repeat users here. That's fantastic. And then soon we will have our own YouTube channel that will host our webinar videos, as well as a Google Plus account where we will probably hold some hangouts related to specific tools. Okay, well that's really all I had to, that concludes my piece of the presentation, and I'll turn it over to Geraldine.
Thank you, everyone. We'll now move to the final polling questions. We will give these questions a couple of minutes and then move on to the Q&A portion of this webinar. Please be sure to stay in the room and or stay on the line to participate in the questions and answer period. Thank you. Okay, let's give the polling questions just another minute or so.
So remember to stay in the room because our Q&A period follows the polling questions.
Okay, I'd like to now move to our question and answer period. Today's Q&A will be moderated by our team scientist, Dr. Brian Krupp. Brian?
Brian, you need to unmute yourself.
Sorry about that. Yeah. Good afternoon, everyone. Thank you for attending today's telecon. I don't see any specific questions relating to the webinar. So if you want to ask anything, if you can type your questions in the box, and we'll do our best to answer them.
So I see one comment here. Let's see, could you show the last link again? And unfortunately, I don't know what this user is referring to, but I would be happy. Okay, the tiny URL. Yes, well, here you go. So hopefully that helps a lot. And I see, okay, Brian, you can start with this one here.
I'm sorry, which one, Jennifer? I'm only seeing part of these things.
Let's see, John Hermans. He goes by Jack. Thanks for listening in, Jack. Okay, NASA has just released the new global rasterized vegetation database in binary format. How might this be provided in or converted by me to ASCII form? So Jack, I know that you've been using a lot of the land processes DAAC data products, and I'm not sure which, and I've got, everybody on, the silent mode just because we've got so many people in the room and I want to maintain the audio quality, but I'm not sure which tools you've been using other than Reverb, if you've used any of the data conversion tools. Brian, did you have any insight into that, into what he might use to convert the data into ASCII?
No, I think checking with the user services people.
That's that's a good question for the LPDAC user services, because from my perspective, and I don't know if you're using GIS, I assume you probably are, some GIS software as well, but maybe, you could shoot me an email and I'll follow up offline with you. Okay, so let's see, what type. Okay, Brian, are you seeing the questions? Form from the shopping cart. Okay, So one other question is, what type of processes could you have performed in the shopping cart? Okay, so there, depending on the data product, Elizabeth, and what you had ordered, that will determine your options. For example, but I will say generally, right, there are some data products for which you could convert the format from its native format, and you could ask for a specialized output. You could ask for GeoTIFF instead of HDF format, for example. Some of them offer KML output or other outputs. You could have subset by bands or channels depending, say you had some air surface temperature data, or you had MODIS data and you wanted to subset by bands. You would be able to subset. In some cases, you might even be able to further subset spatially. It just depends. What else can you do? Oh gosh, there are a number of different processes. There's actually a way for you to just go ahead and get a a link directly to your data instead of going through the whole process once you've registered. I'm trying to think of other processes. Brian, you have anything to add to what one could do? There's conversion, there's subsetting. There is well, it's not necessarily a process, but certainly you can check out the browse imagery if it's available for that specific data product. Do you have more to add to that, Brian?
No, I don't.
Okay. Okay, is it possible to upload a shapefile to download MODIS data for your region? Upload a shapefile to download MODIS data for your region. Is it possible to upload a shapefile to download MODIS data? I mean,
what type of MODIS?
If you're asking whether or not you can do this conduct this action within the tool itself, the Reverb tool, I think the answer to that is no, if I'm correct. However, there are most likely other tools, for example, and I wonder whether you might be able to accomplish something like that by way of the, possibly by way of like the Glovis or the Earth Explorer tool that are actually USGS developed tools that are partnerships with NASA, because those are two tools that you can download ASTER and MODIS data from, and we do have a tutorial for the Earth Explorer. You know, for this user, I will need to check on that for you and get back to you with an answer. How long does it usually take for data to be ordered and received? I mean, I think that this question, it does vary, right? In my case, I conducted a couple of test orders today, and for the ANSWER-E rain swath data, it was immediate. It was within 5 minutes. There was an FTP, pull instructions for me to obtain the data. If, however, you are asking, for example, for an on-demand product like the ASTER on-demand product, there could be a time frame for, I'm not sure what the response time is currently. I would need to check on that, but it could take a few days to obtain your data if there's not been something processed already for your specified region of interest. And I should say that for ASTER on-demand products, if you needed repeat coverage for a specific area over time, you would need to submit a one-page proposal describing your research to obtain approval for repeat coverage for that region. Otherwise, what you're looking at is pulling an already processed level 1B data product from either their data pool or the Reverb holdings, which I should mention, when you're doing a search on Reverb, that goes out to the individual data centers that are holding the data. Just so you know that it's actually not all happening there. This request goes out to the individual data centers. So it really would depend.
It also depends on the number of granules, what size they are. A few years ago, I ordered approximately a gigabyte of Earthdata products, and it took a day or two before
Yes,
everything was staged
that's,
and ready to be
that,
downloaded.
that's also a consideration. Hope I didn't miss anything above. Okay, this is the exact data product. Brian, are you familiar with this at all? You know, I'm not familiar with this data product, Jack, at all.
I'm sorry, which one are you?
The next one down, you see? This is the GIMS 3G NDVI data. And you're saying this is a LPDAC data product, eh? I can't keep up with everything. Wow. I'm not familiar. I'll have to take a look into that. Okay, let's see.
We can get back to you on that.
Brian, you want to get to the next one here in line?
Using Reverb, when looking for information regarding human dimensions, I find many data products which cannot be marked. They say only metadata. How can these data products be used? Okay, that's interesting. For those specific things, I would strongly recommend talking to the user services person at the CDAC data
because
center.
Someone should be able to go ahead and download the CDAC data using Reverb as well. But you know, for this user, you might find it, although, you know, I'm not necessarily trying to promote another tool, but it is a great tool. If you go to, I'm going to type this in here, cdac.seasons.columbia.edu, right? They have a map gallery. I also have a webinar for the CDAC folks, and they have some web services that are available for manipulating those data products. So there's a web mapping tool. It's actually really quite good. You know, there are a number of different overlays, and possibly might be an easier way unless you're also pulling other data products at the same time. I'll have to look into why you're having that issue, because that should not be the issue. But in the meanwhile, hopefully you saw the URL. The mapping tools and the map gallery are very, very useful on the CDAC website. That's actually located at Columbia University. Okay, go ahead. Let's see. The next question, Brian, you got?
Right. Let me expand this. What are the plans to plug NASA data into Web 2.0 interactively, as we have seen with Google Earth and some Esri products, where people can directly load TIFFs into a map composition for analysis?
You know, what I would say from a general level is, I'm not sure whether there are plans at a EOSDIS level, and if there are, I'm not sure what they are. I would say that if there are plans right now, there are probably some data, center-specific plans to do so. But that is an excellent question. I know that we do have I don't know if you're familiar with this, but one of the near real-time map, visualization tools is NASA Worldview, where you have some near real-time MODIS visible imagery. And let's see, map composition for analysis. That is getting close to those capabilities. I would need to look into that, and I will provide you an answer, because that's a very good question for our project. And I think that, that's something. By the way, I should tell all of you that the webinar presentation files below, that feature is persistent. So when we're finished here, right, I can still upload additional files, and perhaps I could answer some of these questions as well, although I'll get back to all of the end users individually. But you could listen to this later, and you could still pull the files at any point in time, and always feel free to email me, and I will, see what I can do. I do work with all 12 of the user services offices at the data centers, and I know all of the user services reps, individually by name, and certainly I can help you get to the bottom of, whatever it is you're trying to find out. But that's an excellent question, and one that definitely I would like to ask the project about. Okay.
All right. The next question, to quote, as far as I know, in some websites, some of the data sets like NDVI or MODIS 9 is not georeferenced, so we need to download MODO3, the MODIS geolocation data for georeferencing. Would you please let me know if there is any other solution?
I am not sure as to what a solution is. To me, if you're referencing, that's a question for LPDAC, unless you have anything to add to that, Brian.
No, there are things like, there are MODIS mapping tools and MODIS reprojection tools, but I would suggest, again, going to the, specifically to the LPDAC user services.
The one tool that you might consider trying, which would you would not need to download the geolocation data separately, and I don't know if you've tried this before, is the MODIS Global Subsetting and Visualization tool, and I will need to add that link. I'll have to add some more links to the additional resource links doc, because that's a tool that's partnership between the Oak Ridge DAAC and the Land Processes Data Center, and this particular tool will process the data for you on the fly, and there is no need to download additional geolocation data. However, what I should tell you is that it does not include, it will not allow you to access all, however it will allow you to access NDVI, all of the MODIS land products, okay? But you will also get with that your land cover characterization, and there's phenology data that comes with the NDVI when you incorporate the use of that tool. So I will include that. I don't know the URL off the top of my head. If I did, I would type it right in for you. I think it's one of the longer types. And we do have a webinar for that as well from our Oak Ridge DAAC. They did a step-by-step on that, and I believe that took place, I want to say, let's see, that might have been July. So that could be a possible solution. After the you upload a shapefile to deal with the Reverb echo, there's actually an option. Search by. So Jose, I have not, that's part of the search that I have not necessarily conducted myself, and I would need to find out a bit more information for that aspect, or take a look at it to provide you an answer. But I will do that. I will follow up, okay? All right, Brian, do you see any other questions?
There's an answer to the shapefile question.
Okay.
From jose.atyus@gmail.com. As to the question before, to upload a shapefile to delimit your area of interest, in the Reverb Echo, there is actually an option on the bottom of the spatial search called Search by Esri Shapefile.
Yes, but that's not uploading. I got the impression that the individual was asking to upload their own. This is a searching by an existing Esri shapefile for that area, correct? Brian?
Right, that was what the previous question was.
Right, so I have to get some more information on that. Are there any additional, let's see, as far as I know. Oh, we've already got, okay. I'm just trying to look through here. I'll provide some more details on, I've probably covered most of the processes, but I will provide some more details, Elizabeth, if you're still on, as to what additional things you could do. I don't see any further questions.
If there are no further questions, then this concludes our webinar. Thank you again for joining us today. Just a reminder that the room will be open for 10 more minutes if you want to download the presentation files. Thank you.
This is Brian Krupp. I would like to add one more quick thing. Today, NASA released a news bulletin. The first imagery from the GPM mission, the Global Precipitation Measurement Mission, is available on their www.nasa.gov site. If you go to News and go down to under News and Features, click on Earth. On the right side, you'll see something NASA GPM Stormy New View, and it's the first release of imagery from the satellite. Data will be publicly available starting in September of this year.
What I'm thinking about doing, I don't know what everyone feels about this, those of you still on the line, is holding a webinar that's like a share-a-thon type webinar where we have several different reps from data centers as speakers, and they give, a shortened, each one of them gives a tour of, one of their tools or their data products, and we delve into a little bit more detail as to the functions and, the key features or functionality for that tool, or the, temporal spatial coverage and how these data products are being used. So I'm thinking about doing that in the months to come, and having some breakout rooms and that kind of thing. That will take some organizing, but that's something that you might see coming in the future. Also, our next webinar will be, the speakers will be from the Langley Data Center. So we will have that on April 23rd. Stay tuned. If you're interested in receiving an announcement, I go ahead and sign up to our mailing listserv. This way I know, and I don't want to send unneeded, or shoot me an email, unneeded messages to people, if you're not interested. But thank you all for participating. I see a lot of repeat participants, and that's fantastic. Thank you. Okay, everybody, we are no further questions. We're going to go ahead and log off the telecon now. And, okay, the webinar materials, all you have to do is click on one of these presentations, and then you download the file. Thanks, everybody. I appreciate you being here today. Bye-bye now. We'll leave the room open for a few minutes.